Hey, all, Brad here with another video. About a week and a half ago, I repaired a early, we call it a Type 1 Williams soundboard, originally used in pinball, and they used it on the early Defender. The customer was complaining it had a hum. He posted on Clav, went over it in a previous video a couple ago. In any case, we thought maybe it was picking up noise from a ballast or some other source, RF source. So he was unable to figure it out. He sent it in. I went through and replaced all the caps and basically did a full rebuild. I couldn't get to duplicate the problem originally, um, but I did test all the caps for capacitance and ESR. There was a couple that were a little borderline, I would say, but no smoking gun. And sent everything back to him. He put it in the game. It's working great. But throughout that, when I was in the process of doing that, I have probably 50 or 60 of the audio amplifier, the TDA 2002s or 2003s, in stock. They're modern, probably Chinese knockoffs, if you will. Um, they they went out of production with the major companies back, 10 years ago or something, 2013, around that time period, from what it looks like. In any case, I've put them in the newer style board, which I'll go over. Never had any issues, and I put one in the board, even though the amp was working, just to, like, as a safeguard since I couldn't duplicate it. And I had a tremendous noise coming out from that amplifier. And I tried all kinds of stuff and struggled. What I ended up doing is just taking one from an older soundboard and putting it in there to replace the one that was on that board, just to make sure, that that wouldn't have been the problem. Since then, I've gone back and really tried to figure out what's the difference between the new boards and the old boards, and where's that noise coming from, and how do we eliminate that? Because I'm sure, I only work on these for the arcade games, but these things are very prevalent on the earlier Williams pinball games, the System 3s and 4s or whatever. And I'm sure people are having amplifiers fail and struggling to get them working as well. So anyway, let me switch over here and I'll go over kind of what we did. So this is the Type 1 early soundboard. This is actually the one that had that hum that I rebuilt. So on this board, I've replaced all the electrolytic capacitors. I've replaced the bridge rectifier, all of the headers here, these Molex headers, switching from the round pin to the square pin, which I've mentioned before gives you a lot more surface area. And over time, those things had a lot of oxidation and wear on them. I also pulled the fuses and recrimp these friction connectors, so the takes a lot of force to push the fuse in and it holds it real tight. Typically, I'll remove the labels and reposition them. This one got stripped down in a simple green bath and that. And I also replaced here. This is the AC coupling capacitor for the input on the audio amplifier, and I did replace that on the customer's board. The original one was an electrolytic here, so we got that swapped out. So anyway, that's an early board. This is they call it the system or Type 2, which is used on the 6 and 7 pinball games, I believe. But pretty much all of the Williams games, the later Defender, Stargate, Joust, Roboton, Sinistar used this with a speech board, Splat. All the games use this board. So I've rebuilt hundreds of them probably throughout doing repairs and stuff. And I've used those amplifiers that I used on which is right here, this TDA 2002, many times. Never had an issue, no noise, no hum, no buzz, anything like that. So I really, again, wanted to figure out what was going on here. So let's go back and look here. So this is the circuit for the early Type 1, the rectangular board. And look right here at the this little triangle here is the amplifier. So it's a 5-pin device. So pin 1 is your main input. Uh, Pin 2, it says negative, which is really where you set the gain at. And then pin 3 is ground, pin 4 is the output, and pin 5 is where you power the device. And again, these have a lot of tolerance with a wide range of voltages. You can power these amplifiers. They were designed for automotive originally back in the late 70s. And you can see this up here. It says plus 12 volts unregulated. So it doesn't have a lot of conditioning to that 12 volts. So it's pretty susceptible to those issues. I've made a couple notes on here. We'll come back to some other fixes I've done um, after looking into this. So let's jump to the power. So this again, this is the type 1 early. And if you look here, so your 12 plus 12 volts comes in up here on pin 1 or 2. They're jumpered. And then your ground is on pins 5 and 6. And then your minus voltage comes in on 8 and 9. If you're running the linear power supply, it's minus 12. If you have a modern one, it's minus 5. That negative voltage is really only used for the digital to analog converter on the board, just as a reference, and it doesn't really get used anywhere else on here. So we're just going to focus on that 12 volts unregulated. So it comes in. Again, these boards from the Pinball era were designed to take AC voltage in. That's why they have the bridge rectifier. We're powering them straight off the linear or a modern switcher, so you really don't even need all that circuitry there, but they left it in place. So it really doesn't hurt anything. Your power comes into pins 2 and 3, and then output on um, 3, 2 and 3, and 1 and 4 are your output. So pin 1 is the plus. In reference to the ground, you get roughly 12 volts of unregulated voltage at this point. And then they did put a 4700 microfarad capacitor here, which gives you a lot of capacitance and smooths out any ripple if there was AC on it. But capacitors that large have a lot of ESR, which is the equivalent series resistance, and they're not very fast responding again. So if there's high frequency noise or noise, it is up to a certain frequency, it's not going to filter that out. And so for contrast, let's look at the the, the later version here. So same circuit, you have your 12 volts coming in, minus 12 ground, bridge rectifier. There's your unregulated 12 volts here in the yellow. But if you look here, they have this little polarized 1 microfarad capacitor here between that on the 12 volt and ground, which is missing from the earlier boards. So that turns out to be the key thing that was causing the problem, spoiler alert. And then let's take a look here at the audio circuit as well for the later board. So the other thing they did is on the input to that amplifier, they put a 1K resistor to ground, which basically, if you have basically no signal coming in here and there's just some noise, that puts a little bit of current draw on this circuit, especially with this capacitor here, just to kind of pull anything. Because the other problem, and I'll go into, is that feedback loop here on pin 2. Pretty much it's used to set the gain. So if you look at what they have here, they have 2 resistors in series, and they're tapping off the center of them, which is a voltage divider circuit. And voltage dividers are ratio metric. So the top resistor is at 220 ohms and the bottom is at 2.2. And the math is pretty easy there. It's a gain of 100, which, these are like 7-watt amplifiers. And if you look at the amplitude of the input signal, 100 is way too much. So you're never turning that volume pot all the way up to, it's a 5K pot. You're never adjusting that up on the volume control over there. So keep in mind, if your volume is set wherever it's set, any noise that comes in is going to be amplified, whatever that ratio is here. So again, the default is 100 to 1, which is an overkill. So if we go back and look at the one sheet that I put here, this is basically where we're going to modify the audio circuit initially. So what I did is I took this 220 ohm out and put 150 ohm to reduce the gain, and which still gives you plenty of volume, believe me, with less distortion as well at the low end. And then over here, we're also going to add that 1K to ground on the input side of that polarized capacitor here that feeds in. Again, the main reason why you put a capacitor in series like that is so you only pass AC and it blocks any DC coming in. And that 1K to ground will just create a little bit extra current before it goes through the cap to pull any noise off. So those are the 2 main mods on the audio circuit, is changing the ratio for the gain to lower the gain, and then adding a little bit of current draw leading up to that capacitor here. So, and then on the power, what we're going to do is insert this 1 microfarad cap, and ideally we want that as close to the amplifier as possible. On the 6-7 type 2 boards, it's back a little further, but they use some pretty heavy duty traces. The other issue on these boards is the ground plane was not thought out very well. Typically you want to do like a star pattern, especially when you're dealing with amplifiers and analog circuits like that. So you want to make sure these boards are mounted to the mounting plate very securely with, steel screws, conductive screws, and that you have good ground strapping and braiding there. So let's switch over. This is going to be a little clunky to my bench cam here, and I'm going to manually do one-handed, kind of show you what we're doing here, and let you listen to the noise with and without that 1 microfarad cap, and then that pull down resistor as well. Whoop, there's my finger. So here's on my bench here, I've got one of these Type 1 boards, and back here under this heatsink is the TDA 2002, and this is actually a 2003, one of the new ones that I bought. And right now I have, let me move this wire out of the way here. Down here we've got, you know what? I've got a little pointer here I can use. Down here we have a 1K resistor that I put right leading into that capacitor for the coupling for the input. And then on the other side here where that red clip is just ground. And that's another decoupling capacitor that was there originally at 0.001 microfarad. And then what I've done is I've taken a 1 microfarad cap and tacked it onto pin 5 of the audio amp, which again is the power where that 12 volt unregulated is. And then right next to it is actually pin 3, which is the ground for that audio amp, which is when we put a permanent fix. I'll show you on the other board where I put it on the backside. But for right now, I just have that coming up to that red lead, which is connected to ground. And then right now, the 1K is just the other end of that blue is just floating here. It's not connected. I'll show you what that's doing. And then over here on the board, we have that 2.2 ohm resistor right here. And then this was originally the 220 ohm, and I've dropped that value to 150 ohm to give us a little less gain just right off the bat. And to show you here, so here is TDA 2002, an older one. And again, for whatever reason, these ones made in the 70s, early 80s don't seem to exhibit this noise problem. That amplifier was later copied and renamed LM383, and those don't really seem to have the issue. It looks like anything made from late 80s onward in the 2002, 2003 has the issue with this noise. This is a modern one, a replacement one that I have here. And it has the issue. But if I run one of the old ones, and I thought maybe it was due to these things, coming from China, but I took one off a Smash TV board. It was an original. They used 2 on that board, that soundboard. I pulled an original one off. You can see the screws were rusted. It had been on there since day one, since 1990 or 89 probably, and it exhibited the same issue with this noise problem. So, and again, here's a Type 2, System 6, 7 board here, and I've changed to one of the new amps here and no noise on that. So you should be hearing the soundboard right now, and what I'll do is let me pull this ground lead off and you should be able to get the noise here. So you hear that hum? Wow. Now if I use one of those older amplifiers, that hum's not there, so it has some internal filtering in it. Again, if I connect the ground, it goes away. And just for this to show you here, I'll hit the test button. And we'll turn it back on. And so by removing that ground off that 1 microfarad filter cap, this is just filtering the 12 volts coming in. It totally removes all of the noise. And then on top of that, if I add this 1K pull down to ground, which right now this that lead here is ground, it even cleans up more. You might not be able to hear that, but I can hear it. But it also does reduce the gain a little bit, so I'll go back into self-test and I'll remove that 1K. So you do lose a tiny bit of gain with that 1K because you're pulling some of that current off to ground, but it does help remove some noise. So anyway, the fix again, just to summarize here, we add let me show you on this other board. So here's one that I've done the mods on. Again, this has the 150 ohm resistor here, and then if you look at the backside, what I did, and I'll kind of zoom in here. So basically, I have a 1 microfarad cap between pin 3 and 5 right there. So the top rail that you're looking at is the 5 volts, and that center pin there is ground. And you can trace that ground all the way back to the outside board where they have the whole plane. And then there's the 1K going from that point just before the input capacitor and then coupled to ground. So really those two mods there, add the 1K, add the 1 microfarad, and then over here you add 100, replace the 220 with a 150 or something in that range, and you've got a rock solid, Type 1 board that can handle the newer um, amplifiers, and it also cuts down on clearly on the noise, even susceptible noise that the old ones had. So with that, I think we're going to wrap this video up, and we'll catch you on the next one. Thanks for watching.